So for the next part of the lecture, we're going to go to another part of North America. We're going to visit a different river system in Washington State, the Elwha River. If I pronounce it wrong. However, this is a fairly steep river flowing from the high summits of the Olympic Mountains passing through several lakes, and then into the Juan de Fuca Strait. So we're going to focus on the lowermost portion of this river. So this lowermost portion has a upper reservoir and a lower reservoir. Here is in the town of Elwha, and it has this river mouth. I want you to note what happens to this river over the next couple of years, based on what you understand about the transport of sediment. So a couple things to point out about this river. First thing is, this river mouth looks fairly wide right here. Secondly, you see is that, especially in this uppermost lake, there is a really big delta forming here compared to what we had just a few slides back. When we had 1990 to what we had in 2006, you see quite a large delta. In fact, you also see quite a bit of silting also up in this lower lake. You might also notice this coastline is kind of it's there. You definitely see some sediment, but not a lot. So in the year 2011, I got to watch this bugger live. It was awesome. They detonated this dam. They kind of tore it down a little bit, and then when they finally got a rather large piece of concrete, they blew it up. It was awesome. The first thing to see is this is right before the lake, when they're starting to lower the lake level, and you can see this huge delta. You can see some, and the river's already forming meandering river in here. You can see some braiding. Now watch what happens after they blow up the dam. First of all, yep, the delta increases, and they took down this dam as well. Notice all that sediment being set loose. Look at that sucker right there at the edge, the right side of the screen. Whoa, that is a Serous Delta. In the following years, up until the present, that delta has grown by about a quarter of a mile out to sea and along a mile of its length. What you're starting to see is, first of all, you're seeing quite a bit of braiding in this upper lake. Notice how the channel geometry downstream has also changed. You go from a straight and sized river to a braiding river. What the heck's going on here? Yeah, this is definitely a transformation. Let's take a look at what happened there. So when you put a dam in a river, Claire's going to put it somewhere here. She's going to put it here for giggles. A couple things start to happen. Get this piling up of sediment behind the dam, just like you saw in that time lapse up there. Now, because that dam is causing the water to slow down, and the sediment, and when you have slow-moving water, all the sediment falls out, and the reservoir that was initially intended to hold water suddenly fills up with silt. Meanwhile, downstream, you run into a completely different problem. So now you no longer have all that sediment in the river. You go from a river where the load and capacity are fairly close to each other to a river where the capacity is much higher than the load. So the river is going to want to downcut, and you're going to get increased erosion. So you notice that downstream of that dam, you have the river incising very deeply into the landscape because all those dams had trapped the sediment that used to sort of replenish some of that. So you get this sediment starve system everywhere downstream, and the erosion rate can increase for miles and miles downstream of that. So in conclusion, rivers trap sediment, and rivers will, with dams, the dam will trap the sediment upstream and increase the rate of erosion downstream. Now, since they've blown up that dam, that coastline has generally been replenished, and they are considering doing that in other parts of the world where the dams have outlived their useful life, and they're seeing some major important returns to habitat. So now for the final part of this lecture, I just want to comment on larger scale patterns of river networks. You've seen this a little bit. I've kind of been teased about it, and we're not going to go into too much of it here just because it's the intro class, but I'd like to bring it up that if you're a river that is incising through basically soft geologic material that's been lying flat for a long time, the network of your creeks, tributaries will sort of have this like tree-like pattern called dendritic. Now, we don't see that much here in California because we have some very active geology. If you go to place, and however, if you go to play, what we see more of in San Diego is because the eastern part of the county is rising faster than the western part of the county. The landscape's being tilted. You also see this in the Great Plains quite a bit. You see what we call a parallel drainage network, where it just kind of looks more like a poplar tree than an oak tree, shall I say. Very elongated in one direction, usually the direction of tilt. Then you have this network right here. What we're looking at from above is the Appalachian Mountains. I think we're somewhere in Virginia last I checked. And you're seeing, first of all, this interesting river that seems to have no bearing on the landscape. One of the cool things about the Appalachian Mountains is they host some of the oldest river systems on the planet, and that kind of makes them extra awesome. The other thing about the Appalachian Mountains is that they formed during the collision of an assembly of Pangea, and that created a lot of folding and metamorphic rocks that were and some of those rocks were much more resistant to erosion than others. So we're seeing in this region and elsewhere is this really awesome pattern of younger rivers are going parallel to the trend of the structure. Older rivers are cutting across it, and because the older rivers are older and have higher cutting down, are more effective at cutting down through things, they're sort of acting as tributaries. So you get this structure we call a trellis drainage structure. You can find another piece of it, but yeah. So you'll see this pattern like this, where you have these sort of like tributaries kind of intersecting at right angles, but there's clearly one major river course that's cutting across the structure, and all the other more minor tributaries are sort of basically following some element of the structure. They can also get interesting things like rectangular drainages. This usually happens if like fractures of the bedrock are controlling where the rock is easily eroded. We see this in certain parts of Texas and around here. You can get radial drainage if you're around a say a mountaintop, or radial drain or angular drainage, this sort of concentric rings if you're around some sort of like basin or dome structure. Now let's take a look at the Mojave Desert. What do we see here? Where are the rivers? Not a lot of them. We do have the Mojave River, which flows out of the San Bernardino Mountains and then kind of disappears, does a big meander around Zyzex, then ends at a Baker, and then you don't see it. Yeah, you have a couple other river systems here. You have this Serous Valley. You have the, which actually does have a lake in the bottom. You have the Panamint Valley, which has a dry lake in it. You have Death Valley. You have this whole system out here where it's really hard to figure out where the rivers are. It's straight, and we call this system a multi-basinal drainage. This is usually an area where some other process is more rapidly changing the landscape than the rivers can. This is generally something you see out in desert environments like the Mojave. Now, perhaps the final I'd love to talk about is this contorted drainage system. Sometimes they call it the drunken drainage system. We actually see a little of that in San Diego County, where the rivers are just going every which way. In fact, remember that river I flew you down, the Sweetwater? Well, our local drainage system is actually kind of weird. We have you see this big structural trend. It looks like the San Diego River should flow this way or something, but no, it does not. In fact, there's a little bit of hill. There actually are some interesting deposits in this part of Alpine, but at one point, yeah, something happened here. Likewise, the Sweetwater River does some weird things, like right where it does this big bend, and then looks like it should go this way, but the main channel goes this way, as if at one point this was a bigger feature in the landscape. And so we call this sort of, likewise, we see this, which looks like it should go this way, but no, this ends up becoming a tributary of the Elwha River and going through here. And so the term we have for that is a contorted drainage system. Now, looking at this, we can actually use these patterns of the river networks to understand how some of the larger geologic structures at the heart of this. Let's take a look at this, or take it in. Yeah.